Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. My name is Alia binti Sashimi. My student ID is 2024247742. Today, I will be presenting my Alice Bookstore system, which is a Java-based application that manages book inventory using various data structures. So, here is the quick overview of what this system can do. The application allows users to manage books using linked list, stack, and queue. It supports operations like adding books, searching, deleting, calculating sums and average, finding minimum and maximum prices, and copying or moving data between different data structures. As a bonus feature, I've also included an infix to postfix expression converter. As you can see, I have 8 classes named book, node, bookstore linked list, book stack, book queue, bookstore app, expression converter, and empty list exception. I also have one text file named book.txt. Let's start with text file. As you can see, the file follows a specific format. The first field is ISBN, followed by title, author, category, price, and quantity. Each line contains a book's information, with fields separated by semicolons. In this file, I have 6 books, 3 novels, and 3 comics. Now, let's move on to the book class, which is the foundation of this entire system. This class represents a book in the bookstore. It has 6 private attributes: ISBN, title, author, category, price, and quantity. All attributes are private to enforce encapsulation, meaning they cannot be accessed directly from outside the class. I have 3 constructors in this class. The default constructor initializes all attributes to empty string or 0 values. The normal constructor takes all 6 parameters and assigns them to the attributes. The copy constructor creates a new book object with the same data as an existing book. This is crucial when I copy or move books between data structures because it prevents multiple references from pointing to the same object, which could cause unintended modification. I also provide public getter and setter methods for each attribute, allowing control access and modification. The toString method displays a book's detail in a nicely formatted way, showing all attributes with proper labels and currency formatting for the price. I also have CalcTotal methods that calculates the total price of the book by multiplying the price by the quantity. This method is used extensively when calculating sums and average in the system. Moving on to the node class. This represents each element in the linked list. Each node contains 2 things, a book object and a reference to the next node in the list. The data attribute stores the actual book object, and the next pointer links to the following node. I have 3 constructors in the node class for flexibility. The default constructor initializes both data and next to null. The second constructor accepts only a book object and set next to null, which is useful when creating new nodes that will be added into the end of the list. The third constructor accepts both a book object and a reference to the next node, which is very useful when inserting at the front of the list. I've also provided getter methods getData and getNext to access the book and the next node reference, and setter methods setData and setNext to modify them. The toString method in node displays the book data and then calls toString on the next node, which is very helpful for debugging purpose. Now, let me explain the bookstore linked list class, which is the core data structures that powers my entire system. This class manages a linked list of book objects and serves as the foundation for both my stack and queue implementations. I have 3 protected attributes in this class: head, tail, and current. The head points to the first node in the list. The tail points to the last node, and the current pointer is used for transversing or iterating through the list. By using protected access, I allow subclasses like bookstack and bookqueue to inherit and use these attributes directly. The class begins with a default constructor that initializes an empty list by setting head and tail to null. The isEmpty method simply checks if head is null, which is a quick way to determine if the list has any elements. For inserting data, insert at front adds a new book at the beginning, while insert at back adds at the end. The insert at back method is very important because it is used when loading data from the text file and also when implementing the enqueue operation in my queue class later. For removing data, remove from front removes and return the first book, while remove from back remove and return the last book. The remove from front method will be used by my stack class for the pop operation and by my queue class for the dequeue operation. For iteration, I have getFirst and getNext, which implement the iterator pattern. The getFirst method returns the first book and sets current to head. If the list is empty, it throws my custom empty list exception. The getNext method moves the current to the next node and return its book, or return null if there is no next node. I also have a size method to count the total nodes, a getLast method to return the last book without removing it, and a print method that displays all books in a format table. So, my stack will primarily use insert at front and remove from front, while my queue class will use insert at back and remove from front, making this linked list class the perfect foundation for both implementations. Next is bookStack class. This class extends bookstore linked list and implements stack behavior following the last in, first out principle. The push method adds a book to the top of the stack by calling the insert at from method from the parent class. The pop method removes and returns the top book by calling remove from front. The pick method returns the top book without removing it by calling the get first method. Other than that, this class also reuse the parents is empty and pre methods, which make the code clean and efficient. This inheritance allows the stack to benefit from all the list operations while adding its own specialized behavior for last in first out data management. I've also added additional functionality specific to stacks. The search by title method search for a book by its title and returns it if found. The delete by ISBN method removes a book from the stack using its unique ISBN. For summary reports, I have three important methods. The CalcSum methods calculate the total price of all books in the stack by summing each book's total price using the CalcTotal methods from the book class. The second one is the CalcAverage methods, calculates the average price per unit by dividing the total price by the total quantity of all books. And lastly, the find minimum and maximum methods identify the cheapest and most expensive books by comparing prices. Now, let me explain the book queue class, which also extends bookstore linked list but implements queue behavior following the first in, first out principle. The enqueue methods adds a book to the back of the queue by calling insert at back from the parent class. And then the dequeue method removes and returns the book from the front by calling remove from front method. The get from method returns the first book without removing it by calling get first. I also have get end method, which returns the last book in the queue by using the remove from back and insert at back methods from the parent class. Similar to the stack, the book queue class reused the parents is empty and pre methods. This inheritance allows the queue to benefit from all the list operations while adding its own specialized behavior for first in, first out data management. Next, let me explain the empty list exception class. This is the custom exception class that extends runtime exception. It is used throughout my linked list and its subclasses to handle situations where someone tries to access or remove data from an empty list. The constructor calls the superclass constructor with a descriptive error message saying the list is empty. By using runtime exception, I don't need to declare throws in every method, which keeps the code cleaner while still providing meaningful error handling when operations are attempted on empty data structures. Moving on to the expression converter class, where it provides infix to postfix conversion using a stack. This class has two methods. The main method is infix to postfix, which takes an infix expression as input and returns its postfix equivalent. It will scan the expression character by character. When it sees a letter or digit, which is an operand, it adds it directly to the output string. When it sees an opening bracket, it pushes into the stack. When it sees a closing bracket, it pops the operators from the stack and adds them to the output until it finds the matching opening bracket, which it then discards. When it sees an operator, it checks the precedence of the operator at the top of the stack. While the stack is not empty and the top operator has higher or equal precedence, it pops those operators to the output. Then, it pushes the current operator into the stack. After scanning all characters, it pops any remaining operators from the stack to the output. The second method is precedence, which assigns priority levels to operators. Addition and subtraction are on level 1. Multiplication and division are on level 2. And exponentiation is on level 3. This ensures the correct order of operations is maintained. Last but not least, the main application class, the bookstore app. The class starts with the main method where I created instances of all my data structures, as you can see in the video. I have a bookstore linked list called bookll to store the initial data from the file, a book stack called bookstack for stack operation, a book stack called backup stack for backup purposes, a book queue called book queue for queue operation, a book queue called novel queue specifically for novels, and a book stack called novel stack for storing novels in stack format. The first major operation is loading data from the book text file. I use file reader and scanner to read the file line by line. For each line, I use string tokenizer to split the fields using semicolon as delimiter. I extract the ISBN, title, author, category, price, and quantity, create a new book object, and insert it into the linked list using the insert at back method. If the file is not found or there's an error, I catch the exception and display the error message. This ensures the application doesn't crash, even if the data file is missing. After loading the data, I display a welcome message and present the main menu with 18 options. The menu includes options to display books, copy data between structures, add new books, search, delete, view summary reports, and perform expression conversion. The menu runs in a do-while loop that continues until the user selects option number 18 to exit. Now, let's walk through each menu option and I will explain what it does. Option 1 displays all books from the linked list by calling the print method. This shows all books loaded from the text file. Option 2, copy linked list to the book stack. Option 3 displays all books in the book stack using the print method inherited from the linked list. Option 4 allows user to add new books to the stack. It asks how many books to add. Then, for each book, it prompts for book details. It validates that price and quantity are not negative. Once all data is entered, it creates a new book object and pushes it into the stack. Option 5, search for a book in the stack by title. It calls the search by title method from book stack, which traverses the stack and returns the book if found. Option 6, deletes a book from the stack by ISBN. It calls the delete by ISBN method, which finds and removes the book from the stack. It prints success message if successful and book not found if the deletion is unsuccessful. Option 7 displays a summary report for the stack. It first checks if the stack is empty. If not, it calculates and displays the total price using CalSum, the average price per unit using CalAverage, and identifies the cheapest and most expensive book using find minimum and find maximum. All results are displayed in a formatted report. Option 8 copies all books from the book stack to backup stack. Similar to option 2, it traverses the stack using the get first and get next, creates copies, and push them into the backup stack. Option 9 displays all books in the backup stack using the print method. Option 10 moves all books from the backup stack to book queue. This is different from copying because it uses pop to remove books from the stack and enqueue to add them to the queue. The pop method removes the book from the stack, so the backup stack becomes empty after this operation. This demonstrates moving data between structures. Option 11 displays all books in the book queue using print method. Option 12 moves only the novels from the book queue to novel queue. It uses the queue to remove book from the book queue, checks if the category equals novels, case insensitively, and if so, enqueues a copy to novel queue. This filters the queue to extract only novels. Option 13 displays all books in the novel queue using the print method. Option 14 displays a summary report for the novel queue. It calculates the sum, the total quantity, minimum, and maximum by traversing the queue using the get first and get next. It displays the total price and the average price per unit along with the cheapest and most expensive novels. Option 15 copies all books from novel queue to novel stack. It uses get first and get next to traverse the queue, create copies, and push them into the stack. Option 16 displays all books in the novel stack using the print method. Option 17, it prompts the user to enter an infix expression, calls the infix to postfix method from the expression converter class, and displays the converted postfix expression. Option 18 exits the program by setting choice to 0, which breaks the menu loop and displays a thank you message. Lastly, the default case handles invalid menu selections by displaying an error message. The entire menu runs in a loop, allowing users to perform multiple operations until they choose to exit. Now, let me demonstrate my bookstore system. I will run through each menu option and show you the output. First, I run the program. You can see the welcome message and the main menu with all 18 options are displayed. The system has already loaded the data from the book.txt successfully. First, I select option 1 to display all books from the linked list. As you can see, all 6 books from the text file are displayed in a format table showing each book's ISBN, title, author, category, price, and quantity. We have 3 novels by Uketsu and 3 comics. Before I copy anything to the stack, let me select option 3 to display book stack first. As you can see, the system shows the list is empty because no book have been copied to the stack yet. This proves that no operation has been performed on the stack so far. So, I will select option 2 to copy the linked list to book stack. The system copies all books from the linked list to the stack and displays the confirmation message, copied linked list to book stack, done, on the screen. Next, I'm going to select option 3 again to display book stack. This time, you can see all 6 books from the text file are now displayed, confirming that the copy operation was successful. Moving on to option 4 to add new books to the stack. The system asks for the quantity of books to add, so I enter 2. For the first book, I enter details such as ISBN, title, Csc508 textbook, author, category, which is textbook, price, and quantity. For the second book, I enter its ISBN, title, Agent Ali, author, category, which is comic, price, and quantity. After both books are added, the system displays success message. Then, I select option 5 to search for a book by title. I search for Csc508 textbook and the system displays the complete details of the textbook that was just added. Finally, I select option 6 to delete a book by ISBN. I enter the ISBN confirms that the book has been deleted successfully. Now, I select option 7 to view the stack summary report. The system displays a comprehensive report showing the total price of all books in the stack, the average price per unit, and identifies the cheapest and most expensive books. Moving on to option number 9. I enter 9 to display backup stack. As you can see, the system shows backup stack is empty because no data has been copied to it yet. Next, I select option 8 to copy book stack to backup stack. The system travels through all books in the book stack and push copies into the backup stack. Once complete, it displays a confirmation message. Then I select option 9 again to display backup stack. This time we can see all books from the stack are now displayed, confirming that the copy operation was successful. Now I'm going to enter 10 to move backup stack to book queue. The system uses a while loop that continues as long as backup stack is not empty. Inside the loop, it pops each book from the stack and enqueues it into the queue. Once complete, it displays a confirmation message. Then I select option 11 to display book queue. This time you can see all books from the backup stack are now displayed in the queue, confirming that the move operation was successful. Notice that the backup stack is now empty because it was a move operation, not a copy. Right now, I'm going to enter 12 to move only novels from book queue to novel queue. The system uses a while loop that continues as long as book queue is not empty. Inside the loop, it dequeues each book from the queue and checks if its category equals novel case insensitively. If it is a novel, it enqueues to novel queue. Once complete, it displays a confirmation message. Then, I select option 13 to display novel queue. This time, you can see only 3 novels are displayed in the queue, confirming that filtering operation was successful. The novels by Uketsu are now in the novel queue. Moving on to option 14, I select it to view the novel queue summary report. The system displays a comprehensive report specifically for the novels in the queue. It shows the total price of all novels and average price per unit. The system also identifies and displays the cheapest novel and the most expensive novel from the queue with their complete details. For option 15, I enter 15 to copy novel queue to novel stack. Once complete, it displays the confirmation message. Then, I select option 16 to display novel stack. Here you can see all 3 novels from the novel queue are now displayed in the stack, confirming that the copy operation was successful. Next, I enter 17 for infix to postfix conversion. The system prompts enter infix expression, so I enter an expression such as a plus b times c. The system processes the input and displays the converted postfix expression, which in this case would be this expression. This demonstrates another practical application of stack data structures beyond just storing the data. Finally, by selecting option 18, it will exit the program. The system displays a thank you message saying, "Thank you for using Ellie's Bookstore app," and the program terminates. That's all from me. Thank you.